Hello everyone, this is the ninth lecture of the data science series using R Python. In this lecture, the topic is regression modeling. Regression modeling is a foundational supervised learning technique used to predict continuous outcomes. Estimation and the evaluation of the regression models involves building the models, making prediction, and assessing performance using the metrics such as mean squared error MSE, R2R, 2RR, and the root mean squared error RMSE. Here we demonstrate regression modeling with the Boston housing dataset in both Python and RPython. The first point is demonstration estimation model evaluation using RPython. Implementation using Python. The first step is import necessary libraries. The second step is load and prepare the dataset. The Boston housing dataset predict the median housing price based on the 13 features such as crime rate and the average number of rooms. The third step is fit the regression model. A linear regression model is trained on the training dataset. Next step is make prediction and evaluate. The trained model predict price for the test set. Evaluation metrics include MSE, measure average squared error between the actual and the predicted value, and the second point is R2R and 2RR. R2R2 indicates how well the model explains with the variability on the target. Observation. Python observation. MSE quantify the prediction errors. Low is better. R2R and 2R2 close in the indicates a good fit. Next, the second point is demonstrate stepwise regression using RPython. Stepwise regression is the statistical methods for the selecting a subset of the explanatory variables that best predict the other outcomes variables. This approach automates the selection of the variables in a regression models by iteratively adding or removing predictors based on their predefined criteria, such as the chi information citation, AIC, or p-value. It is commonly applied in the field like economics, biologics, and social science to build the parsimonious models. Here are the types of the stepwise regression. The first is the forward selection, backward elimination, stepwise selection. The first is forward selection. The first point is start with an empty model, no predictors. Second, sequentially adds variable that improve the model performance most significantly. Stop when the additional variables improves the model criterion. Example, AIC adjusted R2R and 2R2. The second point is the backward elimination. Start with all predictors include. Sequentially remove the least significant variable, highest p-values at each step. Stop when all remaining variables meet the significance threshold. The third point is stepwise selection. Combines the forward selection and the backward elimination. At each step, variables can added or removed based on their contribution to the model performance. Stepwise regression implementation in R. Workflow. Stepwise regression in the R is often performed the step AIC function from the mass package. Here a theoretical outline. First is the data preparation. Begin with the dataset containing the dependent variables and the potential predictors. The second is the initial model. Define the starting model. First is empty model and second is full model. The third point is criterion selection. Use AIC or the other criteria like BIC to decide whether a variable should be included or removed. A lower AIC value indicates a better model. The next point is iterative step. Add or remove predictor based on their impact on the chosen criteria. The next is a final model. The process stops when the no further improvement can be made. Let's see the example of this regression modeling evaluation. First of all, import NumPy as NP, Pandas as PD from sklearn model selection, train test split, import linear regression, and import mean squared error and R2 score. These are the methods are the performed in this code. Generate synthetic data, split data into the training and test set, build the linear regression models, make prediction, model evaluation metrics. Let's run this code. Here, this is the output of this code.